Okay, for this test on Wednesday, it's no more than 10 problems. The first problem, uh, what I will do is to list the differential equation and ask you to tell me whether or not it's linear or nonlinear. So just going right back to section 1, chapter 1, section 1. And then after that, I will list about 4 or 5 problems. You don't have to solve them. Just let me know that if it's homogeneous or if it's exact. Some of them, by the way, could be exact and linear. So if you state both, that's fine. If you state one of what it is, I'm fine with that. Okay? Uh, exactly. Yes, sir. Yeah. So and so the choices that you have are the types that we've considered thus far: homogeneity, separable of variables, exactness, linear, and then Bernoulli. So just those 5. Okay. And that should be just kind of very straightforward. You can look at those problems and tell, okay, what method would I use to solve this? You just tell me that. The next problem, I will give you one application problem here. And I went over some of those problems in the beginning in section 1.3. Matter of fact, I think you recall I added some problems in section 1.3, and those were the problems that I went over in class. So I give you one problem type like one of those, okay? And so I just state here what they were again: population growth or decay, Newton's second law of cooling, or a first order linear equation relative to circuits. And so you can see that in the homework. Also, I think in the syllabus, I added those additional problems. So you can go back and look at that. And the rest of the problems are just straightforward problems that we've been looking at since we've been here in the class. Let me work some of these. I work problems now until the time catches up with me, okay? So let's look at number 3. Huh? Oh, mercy, look at that. Yeah. Yeah, I better go ahead and get it fixed before it explodes, you know. Number 3. Some of these that are listed, there could be problems that I've done in class. If I remember that I did it, I just let you know, refer back to my notes. But I try to work a few of them so you can kind of recall what was happening. This one is separation of variables. Excuse me. Let's see if this will be thick enough. So we're going to separate the variables. At the same time, I can divide a y out here. So this is y times 1 minus x squared dy is equal to y plus 1 squared times dx. So I'm going to separate the variables, get the y's and the dy's together, get the x's and dx's together. So it looks like if I divide both sides by 1 minus x squared, then divide both sides by y plus 1 to be squared. So this is y all over y plus 1 to be squared dy is equal to, divide both sides by 1 minus x. So this is 1 over 1 minus x squared. Divide both sides by 1 minus x squared, dx. So now I want to integrate both sides. This is 1 minus x times 1 plus x dx. Oh yeah, I think we recall this problem now. That left side we had to do just a simple substitution, and that right side was, we integrated that by partial fractions. see. Okay, I need more space. Okay. So for this guy, I think something simple like if you let u equal to y plus 1, this implies that u minus 1 is equal to y. Then obviously du is equal to dy. So I can use that for that left side. Now this right side with the partial fractions, I guess I better stick with this left side first. So for that left side, so I have the integral of here, this u minus 1 is y, so this is u minus 1. That's all over here, u squared. And then the du is the dy. And so that's still equal to that information on the right side, 1 over 1 minus x times 1 plus x dx. So let's break down the right side. Notice here that this left side is easy now. This is just the integral of 1 over u, this u divided by u squared, du minus 1 over u squared du. So that right side, we use that partial fraction decomposition method. So this is equal to some a over 1 minus x plus b over 1 plus x. Multiply through by the LCD, which is 1 minus x times 1 plus x. So just use this space over here. This implies that 1 is equal to a times 1 plus x plus b times expression 1 minus x. And so here, let x equal to 1. If x is equal to 1, this implies that 1 is equal to 2a. That implies that a is equal to 1/2. Now let x equal to -1 to cancel out the a. So if x is -1, then we have a times 0, right? And this is 1 here. 1 is equal to 0 plus b times 1 minus a -1, which is 1 plus 1. So I get 2 times b is equal to 1. My space is running out, so just write b is equal to 1/2. So now I can put everything back in. That left side is the integral of 1 over u du minus the integral. I'm going to write this as u to the -2 du, so I can integrate that. And then that right side is the integral of, is a, the 1/2, over 1 minus x dx, and then plus the integral of the b, which is 1/2 over 1 plus x dx. So let's integrate now. Integrate this 1 over u, that's the natural log of the absolute value of u. Integrate this u to the negative 2, that's u to the negative 2 plus 1, which is negative 1 divided by negative 1. So this is negative divided by negative is positive, bless you, u to the negative 1. That's equal to negative 1/2 times the natural log of the absolute value of 1 minus x plus 1/2 times the natural log of the absolute value of 1 plus x plus some constant. You see how that negative came into life itself? Because if you let u equal to 1 minus x, du is negative dx. Right? Du is negative dx. So you got to have that negative there. So let's see. That u was something in the beginning. That u was the y plus 1. So, and while we're there, let's multiply everything by 2 to get rid of that fraction. So this is 2 times the natural log of the absolute value of y plus 1 plus 2 all over the u, which is y plus 1, is equal to the natural log of the absolute value of 1 plus x all over 1 minus x plus some constant. And you know, with these problems, in terms of simplifying, you can kind of keep working those guys. I'm gonna stop right there. All right. That one I remember working a couple of days ago, so you can check your notes for number 4. Let's look at number 5. Solve the exact equation. Well, it's telling us it's exact, but we don't know, so we better go ahead and check to make sure. So remember that it's m dx plus n dy equal to 0. So I'll take the partial of m with respect to y. Well, this is m here, so this becomes 3y squared minus 2y times sine x. Then I'll take the partial of n with respect to x. So this is 3y squared. And I'm targeting, with this partial, I'm targeting x. So the derivative of cosine x is negative 2y sine x. Well, they're the same. So this differential equation is exact. The dE is exact. So if that be the case, then I integrate with respect to the differentials. So integrating with respect to x, so this becomes x y cubed. What's the integral of sine x? Negative cosine x. So this is negative times that negative is positive y squared cosine x minus 1/2 x squared. Now we integrate with respect to y. So this is 3xy to the third divided by 3. The 3's cancel out. It's just x y cubed. Integrate with respect to y again on this part. So this is plus 2y squared divided by 2, which is just y squared times cosine x is equal to some constant. If I have repetition, I delete but keep 1. So I have x y cubed, x y cubed. I get rid of one of those. Y squared cosine x, y squared cosine x. The remainder is my answer. X y cubed plus y squared cosine x minus 1/2 x squared is equal to c. And you can multiply by 2 to get rid of that fraction there. That's fine. It doesn't matter. Yes. Right there. Okay. Just let me know when you're ready. Just say when. Yes, sir. Exactly. Yes, sir. Is that good? Okay. All right. With the yeah, that'll be fine. That'll be fine, man. Let's look at number 6. Excuse me. Solve the differential equation subject to the indicated initial condition. Now here he doesn't tell us if it's exact or if use some appropriate substitution to give you the idea that it may be homogeneous. But you can look at this problem. It's not homogeneous because, I mean, this is x squared plus 2xy plus y squared. All those will have a power structure of 2. That's good. This 2xy is a power structure of 2. X squared is a power structure of 2. That -1 is not. So I know it's not homogeneous. I would not dare try to sit there and separate the variables. You'll be there until kingdom come, and you'll still be working. The angels will be flying all around you and ask you the question, what are you doing? I'm trying to separate the variables. No, it won't work. No. So it's not separation of variables. It's not homogeneous. And so the question that I beg next would be, is it exact? Is it exact? So notice that m is equal to this x plus y to the second, but that's just x squared plus 2xy plus y squared. So we find the partial of m with respect to y. So this is 2x plus 2y. So n is that 2xy plus x squared minus 1. So we look at the partial of n with respect to x. So this is 2y plus 2x. So indeed, it is exact. So if it's exact, you can use our method. I guess I can say our method now is my professor's method, Dr. Starworth. Lord bless his soul. If he's either up there or if he's down by the fire, I don't know which one, but he passed away. So I guess now I can say, since he's passed away, I can say it's our method because he can't say anything. So anyway, if he comes to me at night in my dream, I tell you, I'd be afraid. No. Anyway, it's exact. So we integrate with respect to dx, integrate with respect to dy. So this is the integral. This left side, we broke it out. We expanded that. That's x squared plus 2xy plus y squared dx plus the integral of 2xy plus x squared minus 1 dy. equal to the integral 0 dx. So we integrate with respect to x. So this is 1/3 x to the third plus 2x squared y divided by 2, which is just x squared y plus x y squared, plus integrate this side with respect to y. So this is 2xy squared divided by 2. That's x times y to the second, plus x squared y minus y is equal to some constant. Now I have some repetition. X squared y, get rid of one of them. xy squared, xy squared. And so I have here 1/3 x to the third plus x squared y plus x y squared minus that y is equal to c. And we're given some initial conditions that y of 1 is equal to 1. When y is 1, x is equal to 1. So we get 1/3 plus 1 minus 1 is equal to 4/3. That's equal to c. So we have 1/3 x to the third plus x squared y plus x y squared minus y is equal to 4/3. Multiply everything by the 3. So we have x to the third plus 3 x squared y plus 3 x y squared minus 3y is equal to 4. Okay. Any questions there? I think that's the same problem that you were asking me at the beginning of class. I think that's the same one. Yes, sir. Huh? Well, good. Okay, it's number 7 and then number 8. If I can do both of them in the 15 minutes that I have, that'll be great. Let's look at this one. This is a good problem, number 7. Okay, I better work this one out. I was going to skip it and just put it on the test, but I'll go ahead and work it. Find the general solution of the differential equation. So this guy, I've checked already, is not exact, it's not homogeneous. I cannot do separation of variables on this. So it could be Bernoulli or linear. Right? Well, let's look at this. If I write this is x plus 4y squared times dy over dx plus 2y equal to 0. If I divide through by this x plus 4y squared, and I have y prime plus 2 over x plus 4y squared times y equal to 0. This is not linear because of this that y squared downstairs, right? This problem is not linear in y. Now, yes, sir, Daniel. What do you mean? For this problem? No, I'm not through. No, my friend. Understand that mathematics gives plausible solutions to life itself. The mathematics never leaves you in a box. We go beyond that, right? So, it's not linear in y, but is it linear in x? We flip it. So here, check. The problem may be linear in x. Well, if that's the case, then it has to look like this. dx over dy plus some p of y times x is equal to some f of y. Let's see. So I go back up here, and then I'm going to divide through by the dy. So I have x plus 4y squared plus 2y times dx over dy is equal to 0. So I'm going to write the dx over dy first. It just so happens to bring along this 2y. And we can divide out the next step. Plus this x plus 4y squared equal to 0. So here's what I have in mind. That's what I'm thinking. Right? Besides the chicken wings that I have upstairs, that's what I'm thinking. I'm a very simple man. You think about money? No. You know. Think about other stuff. Food. That pretty much drives me. So this is dx over dy. I have it there. I got to divide through by that 2y. So we get dx over dy plus this 1 over 2y times x plus 2y is equal to 0. So it looks like if I get this 2y to the right side, I think I have it the way I want it. So this is dx over dy plus 1 over 2y times x is equal to negative 2y. Well, let's see. I have dx over dy by itself plus some function of y, which is 1 over 2y, times the x by itself. X by itself is equal to some function of y alone. Let's see. I'll use this side over here. So my integrating factor, mu, is equal to e to the integral of 1/2, and this is 1 over y dy. So this becomes e to the natural log of y to the 1/2 power, which is just y to the 1/2 or the square root of y. So the left side is the product of the derivative here with respect to y of the integrating factor y to the 1/2 equal to the right side multiplied by the integrating factor. So this is negative 2y times y to the 1/2. This is negative 2 times y to the 3/2 power. All this money that the college has, we can't fix this crazy screen. But anyway, so I'm going to integrate this left side. This is with respect to dy is equal to negative 2 times the integral of y to the 3/2 dy. The left side is automatically the integrating factor times the dependent variable is equal to integrate over here. This is negative 2 times y to the 3/2 plus 1. That's 5/2 divided by 5/2 plus some constant. So this is y to the 1/2 times x is equal to negative 4 over 5 times y to the 5/2 plus c. Multiply, well, divide by the y to the 1/2, so x is equal to negative 4 over 5 times y to the 5/2 divided by y to the 1/2. That's y to the 5/2 minus 1/2. That's y to the 4 over 2. That's y to the second. Plus c times, or c divided by the square root of y. The same thing as y to the 1/2 power. All right. Well, there's one problem left there. That was that Bernoulli problem. Here was the thing. That was like number 17 that was listed from section 2.5. I was going to work that then, but I thought I would have time to work it now, but I only have 4 minutes, so I don't have time to finish working that. Again, it's very straightforward. Let me just set this up for you, and you can finish it. This is dy over dx. Let's break this down. This is equal to x times y to the 4th minus y. And so I'm going to write this as dy over dx plus y is equal to x times y to the 4th. Divide through by y to the 4th, so this is y to the negative 4th dy over dx plus y divided by y to the 4th is y to the negative 3rd. That's equal to x. Let u equal to y to the negative 3. Let's see if that picks up the y to the negative 4th. So this implies that u prime is equal to negative 3 times y to the negative 4, yes, times that y prime. So that implies that negative 1/3 u prime is equal to y to the negative 4 times y prime. Well, that picks up this term here. So we have negative 1/3 times u prime plus u is equal to x. So this problem here is now being reduced to a function of this u. Multiply everything by that negative 3. So I have u prime minus 3u is equal to negative 3x. You should be able to finish that from there. This is linear now in u. So okay, so you should be able to finish that. All right. Test will be on this Wednesday. Thank you.